Oh, did I turn tracking on? I might have. Okay. We're back. All right. You guys just can't handle it, can you? You can't handle Ross? Robbie. Okay. All right. 73. Let's talk about, really? You'll get so used to it, you won't even notice. There we go. Okay. Let's talk about 73 here. What are valence electrons? Outermost electrons. Good. So you know valence means outer, right?
Yeah.
Which means core means inner. Okay, so I'm going to go a little off script here and give you a configuration real quick. 1s, 2s, 2, 3, 4. Look at that configuration for a minute. And to yourself, just figure out how many outer versus how many inner electrons there are. So how many valence versus how many core, please. Take a minute. Oh, yeah. Okay. All right. So, what do you think? How many valence electrons?
6.
Robbie says 6. How many of you agree with Robbie?
Yeah.
Does anybody want to say something different? Anybody want to go with 4?
I do, yeah.
How many people aren't sure they know? Most of you are off camera, so you can raise your hands. Okay, yes, I will explain it. Because, so you know what valence and core means, but then we need to translate that to, but what does that really mean, right? Okay. The words inner and outer refer to the energy levels. Okay? So when you look at this configuration, 1s2, 2s2, 2p4, just for a second, ask yourself, what is the outer energy level on this configuration?
2p.
Come up with an answer. What is the outer energy level? I actually told you this when we were talking quantum numbers. There's energy level, sublevel, orbital. What's the energy? What up there represents the energy level? The 2. How many places do you see 2? 2 places. Right? How many electrons in 2s? 2. How many in 2p? 4. How many total on the second energy level? 6. So the answer is 6. Does that make sense? What's left? 1s2. So for this, how many core electrons? 2. So 2 core electrons, 6 valence electrons. Okay? You want to do another one?
Yeah.
Good, me too. Should we go a little bigger? Let's go bigger. We'll go 1s2, 2s2, 2p6, 3s2. We'll go with arsenic again. 3p6, 4s2, 3d10, 4p3. That's our good old friend arsenic. Take a minute, figure out number of valence electrons, number of core electrons, and I'm purposely making this look, wow, even my dots are totally not lined up. You work on answering this question. I'll work on making vertical dots. We all have our goals. Okay. Okay. So what do you think? What is, first of all, remind me again, where do our valence electrons come from? The outer, what? Energy level. What is our outer energy level on this example? 4. How many places do you see 4? Twice. How many electrons in each of those spots? 5. Right? And let me tell you something. I'm guessing you already know this where you can double check for yourself. Because how many of you memorized last year this column has 1 valence electron, 2, skip the lower ones, 3, 4, 5, 6, 7, 8, right? Look at where arsenic is. It's in column 5A or 15. I don't know. They change the way they do those numbers. It's in the 15, group 15, right? Which means 5 valence electrons. So you already know this. The configuration should confirm it. Then you can do some algebra here if you want, or you can count. What's 33 minus 5? 28. So how many core electrons must there be? 28. And you can double check. 2, 4, 10, 12, 18, 28. Done. Boom. Okay? So that's all that is. Does that make more sense now? Okay. Any other questions? Okay. So let's go back to 73. 73C. What does each box in an orbital diagram represent? So we already discussed this. Each one of these is what? It's an orbital. Okay. Let me just give you a little rundown here. Let's say that's 2s, right? The 2 is the energy level, and the s is the sub-level. Okay? So those are the 3 different options there. Okay? What is represented by the half arrows in the orbital diagram? So let's make some arrows. What's represented by those arrows? Electrons. Okay, so those are the electrons. And why are they pointing in opposite directions? Because they have opposite spins so that they can share space. Okay, good. All right, 74. For each element, indicate the number of electrons, the number of valence electrons, core electrons, and unpaired electrons in the ground state. Is anything there kind of tricky for you? The unpaired electrons part? Are you leaving? Oh, okay. I wasn't sure if you had an early dismissal or something. Okay, so the first one, let's look at the first one together because it's nitrogen, right? And we already looked at nitrogen, didn't we? So I'm going to scroll back to this. We said that configuration B was the correct configuration for nitrogen, right? So let's look at this for a second. Look at this configuration a second time, okay? How many valence electrons does nitrogen have? 5. Okay, how do we get that? You could, from the periodic table is the quick and easy way to do it. Or 2 plus 3 is 5, right? You could do it that way. How many core electrons? 2, either because 7 minus 5 is 2 or because you can see 2 in 1s. What do they mean by unpaired electrons? Elizabeth? Yeah, unpaired. Okay, so when they're asking you about that, you kind of have to sketch the orbital diagram for yourself. Now, let me ask you a question. I'll do one more with you from this to kind of give you a little bit of a clue here. So let's do silicon together real quick, okay? do I have to sketch the entire orbital diagram for silicon to figure out who is unpaired? Huh? I don't. How come? Where are any unpairings going to happen? Only in the last sublevel, correct? So look at silicon for a second, okay? Again, you can look at the periodic table. How many valence electrons should silicon have based on the group it's in? 4. How many electrons does silicon have total? 14, which means if 4 of them are valence, how many of them are core? 10, because 10 minus 4 is, no, 14 minus 4 is 10, right? Okay, so then tell me, where does silicon end? In P, right? How many orbitals in P? How many orbitals? Vocab word. What's an orbital? A box. So how many orbitals in the P sublevel? 3, right? Okay. How many, where is silicon? Which P?
2.
Not 2P. 3P. Because remember, the P's start with 2.
3P.
Right? So it's in 3P. How many boxes over? 2. So 1, 2. Do you see how I just did that? How many unpaired electrons? 2. How come I don't have to draw all the other stuff? Because they should all be paired. If we're in P, if we're in 3P, that means we already went through 3S, didn't we? Mm-hmm. So that's why you only have to look at the orbital that you're, the sublevel in the orbital you're ending in. Okay? So do chlorine real quick. Try chlorine for yourself. My guess is maybe you didn't get it done the first time in your 20 minutes. Maybe you did, though. But another example of maybe you did and you have a rough draft, so let's turn it into a final draft. Okay. I just wanted to make sure we can. Okay. So I don't care when, other than final draft by Friday. Right. So is it on paper, or so if you have it, you can just give it to me. Otherwise, just submit it through Schoology and send me, so that I look at it. And if I don't do that by tomorrow, you come and bug me and say, hey, when are you going to do this? Okay? So that's fine, but I want you to get the feedback. So, all right. Chlorine. How many valence electrons does chlorine have? 7. How do you know? Because it's a halogen, right? 7 valence electrons, 17 total, which means how many core? 10. Okay, what orbital am I drawing here? Or what sublevel?
P.
Which P? 3P. Okay, and how many electrons am I putting in here? 5. 1, 2, 3, 4, 5. How many are unpaired? 1. Okay, see how that works? Okay, now I'm going to show you something before we go on to the next problem. I'm going to give you a little cheat way to figure out configurations because I said you couldn't use that pretty periodic table you made last year. So you're going to need something, right? Watch. This will help with multiple things we're working on right now. 1s, 2s, some of you maybe have seen this. 3s, 4s, 5s, 6s, 7s. Okay? If you count your s's, 1, 2, 3, 4, 5, 6, 7. Are you with me there on the periodic table? 1, 2, 3. Okay. Then we go over to p's. Each sublevel starts with the next number. So S is the only one that starts with 1. P's start with 2. So I'm going to put it on that same row as 2S. And then I'm going to go 2P, 3P, 4P, 5P, 6P, 7P. Because that's how many P's I can see on the periodic table, right? 2, 3, 4, 5, 6, 7. Is everybody with me? Okay. What's my next sublevel? D. What number do my D's start in? 3. So then I have 3D, 4D, 5D, and 6D. What's my next one? F. What number? 4s. 4F and 5F is what I see. Okay. Do you understand how I just made that for myself? Okay. This would be a good one to take a picture of before I mess it up, because I'm about to mess it up. Okay. All right. I'm switching to red. So when I'm writing configurations, how do I know what order they go in? I make these nice diagonal arrows that show me 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S. Do you see how I'm doing that? Me, who's challenged to do anything in a straight line sort of format, can do this. So you can too. But that's like, if you're taking a test and you're like, crap, I'm not remembering what order they go in. Well, just draw this for yourself on a scrap piece of paper and start drawing lines, okay? That's all you need to know. So learn how to draw this and then learn how to make the lines and practice writing it for yourself so that you are neat. I don't know if you noticed, but I was being pretty intentional about like making my columns and my rows somewhat neat compared to how I normally write, okay? Now, we're going to go back to, and I have like 3 minutes, so I'm just going to do one for you real quick. Let's look at 76, okay? And while I'm getting ready to do 76, I need you to listen to me. I finally realized how to use that AP Classroom thing, okay? In my homeroom this morning, they are going to be my guinea pigs with making sure I've set it up correctly because I'm going to make them do it. Those of you not in my homeroom are going to get an update like, ha, we did it. Get on there and do it too. You have until, I think, Friday at 9:45 to get it done. There will be, I think, 7 questions. 6 of them are multiple choice. 1 of them is a free response question. They are AP style. They are good questions. You are getting a formative quiz grade, meaning you just get it done, and you will get 100. There is no benefit to you to cheat your way through it because that is your preview into test-style questions. You shortcut it, you shortchange yourself. I'll give you the 100 anyway, but you're going to fail your test. Okay? So, do it. Anyway, let's talk about 76 real quick. What does it mean when they say condensed configuration? Does anybody know? Okay. I'm going to talk magnesium because that's all I have time for, so pay attention. Magnesium's configuration, if we write it out all together, is 1s2, 2s2, 2p6, 3s2. Okay? You know when it gets bigger, these get insanely long, right? The condensed figuration means you take the core electrons. I'm using that word again, core. And you abbreviate them with the noble gas. Neon represents the core electrons. So you look at the last noble gas that you passed. Okay, last noble gas that you passed. For magnesium, the last one was neon. Then I go with 3s2, and that's the rest of my configuration. Okay, so I know neon takes me to 2p6. Where do I go next? 3s2. That's what they mean by condensed. And neon has 0 unpaired electrons. Okay, so listen, the bell's going to ring, but you're going to sit till I'm done.